Hi guys, welcome to today's lesson. So today we're going to be looking at some similarity riders. What are riders, guys? Riders are questions that are geometry based, right? So you know when I give you algebra and I give you solve for x and all of that. So the solve for x, we call them riders, but with that one is because it's a straightforward thing. It's just a solve for x question. These ones, we call them riders because you need to apply the theorems that you learned. You need to then incorporate some other theorems that might not be at that grade that you're doing the math. So it's more of just a question that requires a lot of knowledge about the subject matter you're doing, in this instance, the geometry that we are looking at here. So let me just show you the map of what we are going to look at, which is the same as what we did in the previous lesson, by the way, which was the similarity theorems that we looked at. So let's just look at that and then try and solve some questions, just so that we can put everything we've done thus far into perspective. So what do I know? I know that similarity has some theorems in it, which are the midpoint theorem and the Pythagoras, and also it has some proportionality, similarity, and equingular, right? Then the riders, I said to you, times you will be required to show that triangles are similar, given that the sides are in proportion, or they will want you to find some lengths there. That's when they give you, if is equal to 20, then find, you see. So those are those kinds of questions. Now we have what we call equingular triangle theorem. Remember in the last lesson we spoke about the converse of this, right? This says if two triangles are equingular, then the corresponding sides are in proportion, right? And then consequently, then they are similar, because as soon as the sides become in proportion and the angles are equingular, immediately we are talking about similarity. And then my reason is normally equingular triangle. Now also we have what we call the proportionality theorem, which says a line drawn parallel to one side, right? So this is drawn parallel to one side of a triangle. This thing divides the two sides proportionally. Please, guys, to divide does not necessarily mean it passes through the midpoint. The midpoint theorem is also under proportionality, but that's not what this is about. So let me draw the diagram and show you what I mean, which I know that you are familiar with this, right? So there's my triangle there. If I draw a line that is parallel to one side of this, the two remaining sides will then be cut in proportion, right? So if this is A, that is B, that is C, that is D, it means that A over B will be equal to C over D, because of the fact that these sides are parallel to one another. So that's what proportionality theorem says. And then your reason that you normally use will be line parallel to one side of a triangle. Now when solving some riders, guys, because I know this is one of the problems that you guys are dealing with, I then said, no, let me just try and give you some information that I know will assist you in solving this. One, make sure that you identify the information that is given and mark it on the diagram. What do I mean here? As soon as I say to you, line 1 is parallel to line 2, immediately you need to think about the properties of those of parallel lines. I might have alternate angles, I might have corresponding angles, I might have co-interior angles. I must go to my diagram and show them on the diagram. As soon as I say to you, this line is a tangent to this circle, then you must think about things like your tangent chord theorem and the tangents from the same external point are equal, and then go to the diagram and just mark it with a highlighter or a colored pen so that you can always trace back. Don't just read the statement I give you like you are reading a novel, guys, please. The first time, read it so it can be at the back of your head. The second time, read it so that you can apply it then on the diagram before answering questions. You will see all the questions I have here I start with the statement and the diagram and then follow with the question. Why? Because I don't want you to immediately look at the question without even knowing what the statement means, right? So that's what I'm going to try and show you. Then, the second point is you link what is asked to an appropriate theorem. As soon as they want you to find a side, make sure that you mark the triangle that they want it from, or you mark the square, or you mark the shape that they want you to find, whatever that is asked in the question. Then you always give a reason for each step unless you are adding things. So for example, if you said x is equals to 20 degrees, and you said y is equals to 70 degrees, you must give reasons for these two things. But when you then say x plus y is equals to 90 degrees, you don't need a reason here because you just added these two numbers and got 90 degrees. But any claim that you make, you must have a reason for it. Remember, we said in geometry, monkey see, monkey do does not apply. Because it looks like it, really it does not make it it. So make sure you always tell me, why do you think this is this? Why do you think this is that? And then lastly, you label similar triangles. This is with respect to similarity, right? And then in order of their corresponding sides. Let's look at the first question. What did I say? I'm just going to give you the statement, give you the diagram, we play around with it, and then we look at the questions. So they are saying PQR and PST, the two triangles, are right-angled triangles, right? With RQ being equal to SP, which is equals to 2RS. So what will I do? I will then say, let me let my RS to be X. It makes QR or my RQ to be 2X, and it makes my SP to be 2X as well, you see. So already I've added that information. It was not there on the diagram, but I'm adding it because they told me that RQ is equals to SP, which is equals to 2RS. And then T is a point on PQ such that ST is perpendicular to the PQ there. So you can already see there's a 90-degree angle there. So on this diagram of mine, I'm just going to add what we just added, the x, 2x, and the 2x, because it will come in handy somewhere when we are solving this. Then now what do they want us to actually now do? Show that the two triangles are similar, right? I said always go to the diagram, highlight what they want you to show. So PQR, I'm going to highlight PQR. There is PQR there. And then I'm going to use a different color just to highlight the other one, which is PST. So PST will be that one there. So I must prove that those two triangles are similar. You see, already after highlighting them, I can already see that P will be my common angle, right? So I will immediately then say P is common, right? I know this because both of them have P. And then you can see that I have a 90-degree angle there. I also have a 90-degree angle in the red triangle. Therefore, I use that. So I will then say, because R is in PQR, I will just say R is equals to then the T, because there's a lot of them, I will have to specifically say which one it is. And I will say STP equal to 90 degrees, and this will be given. They gave you this. You do state, even if I gave it to you in the statement, that I am saying this because I was given this information in the statement. You don't just state it and then think, no, because I gave you, then I will see it from there. Then automatically you know if I have two pairs of angles equal, it means the last one is also equal because of remaining angles. So I will therefore say Q will be equals to the angle in the smaller triangle, which is S, so it's TSP. And my reason for this will be remaining angles, right, of a triangle. But normally, you know, remaining, you use REM. You don't need to write the whole thing. Therefore, I can then claim that the two triangles are similar. P QR is similar to triangle PST. And what will be my reason? Equingular. Angle, angle, angle. It means one and the same thing. The second question now wants us to then do what? Prove that ST is equals to QR multiplied by what we have there. And we're going to use a ratio. But before that, I'm just going to quickly add what I know. That is x, that is 2x, and that is 2x, right? As we've done with the previous questions. So using the theorem of Pythagoras, I will then first find what QP is. And the QP squared will then be equals to 2x, all of this squared plus the 3x. And where do I get the 3x from? I get it from adding the x plus the 2x, right, which is the side RP. And then I simplify this quickly. This will give me 4x squared plus, and this will give me 9x squared. And this will be equals to 13x squared. And then my QP will therefore be equals to square root of 13x, right? And that will be the value there. And then I try to find how can I then link QP to anything that I spoke about. Remember the ratio, the similarity that we proved. PQ can be linked with the PS there, right? So I'm going to go to that side. I'm going to just write it up here. We said PQR was similar to PST. PST. Then I link the ratios. PQ will go with PS. Do I know what is PS? Yes, 2x. And then I link also QR. And why do I link QR? Because I know what QR is. And I must link this with ST there, which ST in this instance, I will not know what it is. So maybe if I link it to the PR, so PR will go with PT, right, which I also do not know. So I will then try to find what ST is, because that's what they want me to do. So I'm just going to write the ratio quickly for us. This is PQ over QR, I said, is equals to PS over ST. Let me substitute everything that I know. PQ, we just found it to be square root of 13x over QR, we were given as equal to SP, right, which I said was 2x. So this is 2x, and then this is equals to my PS is also 2x. Then all of this is divided by the ST, which is what I'm trying to then make the subject of the formula. So I will write the ratio. It's square root of 13x over 2x is equals to 2x over ST. Let's just verify quickly. It's PS, and that's 2x, yes. ST, and that is what we do not know, right? So if I solve this, then I know that I will find the x and the x can always divide each other, right? Then I will be left with square root of 13 ST is equals to 2x multiplied by the 2, right, which is 4. And therefore, if I solve for ST, this will be equals to, you divide both sides by square root of 13, right? So this will be 4x over square root of 13. But remember, what were we told? We were told that my RS, my QR, I mean, which is what I know, was 2x, right? So already from this part here, we know that is my QR, right? Yes, that is the QR. Therefore, it means this is the same as QR multiplied by 2 over the square root of 13, and that is equals to ST, which is exactly the same as what they wanted us to prove. and then that's about it. But if you want to write it in that form, you can just also do that. QR times 2 over square root of 13, and that will be ST, and you will then be done. So here, guys, the main thing that you need to always try to do, especially with similarity, you always need to go back to the two triangles you proved to be similar, right? On those triangles, write down the ratios. See what is it that you can let maybe be x, because you are avoiding this thing of always saying AB, BS, PQ, ST, because it's a bit longer to then work out when it's like that. But when it's like X and Y and Z, then it's easier for us to do that. But you don't do that without telling me that let this be this. So you can't just introduce X out of the blue. You must tell me that let AB equal to X. Then I know wherever there must be AB, I'm going to see some X there. Guys, I hope this clarifies a few things, especially when it comes to how to use similarity to then prove some of the other ratios that they normally ask us. For now, get a glass of water, just stretch a bit, and we'll be back just after the quick ad break.